This video will focus on interpretation of NMR. It's sometimes seen as a tricky topic, and my focus will be on how to interpret NMR. So I have about a couple of not a couple, 3 or 4 spectra which I want to interpret in this video. Firstly, a question in front of you, it says integration values are given, and you're given a key information, and the key information is this one here, which is basically the values which you need. And remember, in order to attempt this questions, you need your data sheet in front of you, and the data sheet you're looking at the table B and table C. Table C will be for carbon 13, and what we'll start with is here, where we're going to look at um, the interpretation of this. Okay, so let's have a look at how to tackle a question of this nature. Okay, so we know our molecular formula C6H12O2, and I want to focus on here this, the peaks that occur at the zero end. So remember, the proton NMR ranges from 0 to about 12. That's your chemical shift value. Remember, you've got to read the theory behind this yourselves. And let's focus on some key information. Triplet. If you have a triplet here, that means whatever that is, it's neighboring something like that, a CH2. Okay, so let's start with these integration ratios. We need to convert these into whole number, so I'm going to divide throughout by 0.3, and I will get 22233. Your integration ratio should add up to the number of hydrogens in the molecular formula, which is 12 here, and you can see you've got 12 there. So my whole number ratio is that. Now let's interpret. So delta 1.1, so delta 1.1 is a CH3 because there are 3 hydrogens there. It's a triplet, that means it neighbors a CH2. So this 1.1 and this 3.5 are these two connected. Now why did I pick the 3.5? Because it's a quartet. A quartet means a CH2, those 2 hydrogens next to 3 hydrogens. So that's my doublet triplet there. Also, it's at 3.5, which means it's next to an oxygen. You just select that from your data sheet. The data sheet tells you that something around 3.7, around 3.5, there is a oxygen connected there. Now you've got a singlet, and that's a 3, and your data sheet tells you that something in that region around 2.2 is next to a C double bond O. How do I know it's a CH3? Because I've got 3 hydrogens in that range. I've also got 2 triplets. One of those triplets is at 2.6. So 2 triplets means CH2, CH2. So a triplet quartet, CH3, CH2, 2 triplets, 2 CH2s, and a CH3CO around 2.2. See this CH2 at 2.6, it must be connected there. That means I've got a CH3CO at 2.2. I've got a CH2 there because I've got a CH2 at 2.6. It's a triplet, meaning it's next to another CH2. That CH2 is at 3.7, which means it's next to an oxygen. And then you've got a triplet and a quartet, and that is basically what the top one above is. That's your structure there, and that's correct. And you can see there, triplet quartet, 2 triplets and a singlet. Double check with your data there. The next question is this one, C6H14O2. Now this question again, it's a lovely question to do as a practice one, and I just want to look at this question with you in order to interpret this question. They've given you infrared, so you can see this is OH in alcohols. Please use your table A from your data sheet. The question also tells you that when R is warmed with potassium dichromate, a green solution is formed, which means R must be a primary or secondary alcohol. It can't be tertiary because it's getting oxidized. How do I know it's an alcohol? Infrared tells me it's an alcohol. Okay, there are 5 peaks now in the in carbon 13. Other things I can say, that R is not an aldehyde because there is no CO peak in the infrared, and definitely not a carboxylic acid there. So that bit you know now. So we know R is a primary or secondary alcohol. So straight away, this peak here, okay, this singlet here must be OH. So that peak at 3.1 must be OH. Now let's interpret each peak at a time. This time they've given you the integration ratios. And what I'm going to do is I'm going to take a pencil in the exam and write what this means. CH2, a singlet CH3, a triplet CH2. So again I have 2 triplets, which means I have 2 CH2s. One CH2 is at a delta 3.8. 3.8 means that must be next to an oxygen, and one CH2 is at delta 1.4. So I'm beginning to interpret my peaks. Okay, so actually I've interpreted this peak, I've interpreted this peak, I've interpreted this peak, because at delta 1.1 I have this arrangement there. I've got 2 CH2s, I've got an OH I've got to attach somewhere, and this one has 2 oxygens. And look at 3.1, we said that's an OH, and see this one at 3.2 and 3.8 means OO. So that 3.2, it's a singlet, so that means that 3.2 is a singlet, it must be next to CH3. O attached to CH3. How do I know it's a CH3? This 3 is telling me it's a CH3. So now what do I have? I have, let's attach it here. I have a CH2, I have a CH2, I must have OH here and OCH3 there. Now, why can't it be this structure? The reason why it can't be the one I've drawn here with the circle is because it can't be a tertiary alcohol. However, this structure would get you 90% of the marks, and this structure will get you 100% of the marks. Now look carefully. You've got 2 CH3s, delta 1.1, tells you 6 hydrogens. You've got 2 triplets. This one is towards 3.8, which means it's next to an oxygen, and you've got a singlet around 3.2, so that's your OCH3. Hence, there's your interpretation of that spectrum. That's all NMR is. If you can understand that part, then you've actually understood all of NMR. Now, lastly, the one I want to look at is I want to look at this question in front of you, because I think that's an important question. Again, OH in alcohols, and there's no CO peak, so it's an alcohol. And then I'm given this data. Let me get the molecular formula, because you need that. C6H14O, and there is an OH peak. So let's do the integration ratios. Divide by 0.4, 1, 4, 3, 6. Means there are 2 CH3s there, there are 2 CH2s there. However, something really important to note now. The 2 CH2s are not next to each other, because if there were 2 CH3s next to each other, you would have 2 triplets. You've got a triplet here, you've got a quartet here, which means that you've got a CH3 and a CH2. So here you have a CH3 next to CH2 because of the n+1 rule. If something is next to a CH2, then that will be a triplet. So in other words, you have got a CH3, CH2, but you've got 2 of those in the same environment. How do I know it's 2? Because I've got 4 hydrogens there. It's a quartet, which means there must be 2 CH2s, each CH2 in the same environment connected to a CH3. I've got 6 here, which means 2 CH3s. So my structure must be, and let me do it here in the red, I must have a CH2, a CH3, a CH2, a CH3. Yes, and what else am I missing? I must have an OH, and one other thing I am missing is this single here, which is a CH3 on its own. So that CH3 must be attached here. So my structure becomes CH3, CH2, CH3, OH, CH2, CH3. So just to recap, a triplet and a quartet means 2 CH2, CH3. I've got 2 of those in the same environment because I don't have any 2 triplets or anything like that. That's a very brief video on how to interpret NMR, and I feel that if this question here, you can understand exactly what's going on in each one of these, and then it's a question of putting those together. So do summarize this, watch this video, slow it down in order to understand and